evening, everyone. I'm Calvin Joseph, and today I'll be conducting the NPTEL the problem solving and doubt clearing session for network analysis course. And we will be considering for week 7. We will be solving some sums from the previous year's assignment, as well as we'll be also covering. I'll also be covering certain theory. So if you have any doubts and any queries, you can ask me also. So I'll share my screen. Are you guys able to see my screen?
Yes.
Yes. Okay. So it would be good if this session is interactive. Okay, well, you guys can give me responses and feedback regarding whether you have understood what I have explained, as well as what doubts, etc. you guys have. So you can let me know. So today we'll be doing week 7. And we will be we'll be solving sums which will consider Thevenin's theorem, as well as Tellegen's theorem, and compensation theorem. So these theorems are valid for linear systems. And can anyone tell me what is the most basic theorem which is applicable to linear systems? Like which theorem is applicable for linear systems? It's a very famous theorem which we use in Thevenin's and compensation theorem. In their proof, there's a theorem which we use for them. Yeah, correct.
Thevenin's theorem. Thevenin's theorem.
No, superposition theorem. Okay. So,
Thevenin's theorem.
So superposition theorem is a very important theorem. So superposition theorem is like a sort of backbone on a foundation on which we build the other theorems, etc. So can anyone tell me what is superposition theorem?
For any linear bias network, we are considering only one source and removing the other source with their internal resistances or impedances.
Okay.
Then by applying the superposition principle, we can found the algebraical sum of all the currents due to individual sources.
Okay.
That is the summation of current due to individual sources.
So it is only applicable for current.
Sir?
So superposition theorem is only applicable for current.
No, sir. No, sir. From this, we can found a current, power, voltage in any branch or across any element.
Power does not obey superposition theorem. Power does not obey. Current and voltage.
No, sir, I want to tell that we can find the power across any element.
Yes.
I want to tell that, sir.
Okay. So, superposition theorem is there. So basically, there is a network. You assume you have a network. Okay. You have a voltage source connected to one part of the network. You have another voltage source over here. You have your current sources here. Suppose you have some impedance Z over here. And you have some current I over here. Okay. So this current I, which is flowing out, is a function of V1, V2, I1, I2. Now, when you apply superposition theorem, what will you do? Well, suppose I want to just consider only voltage source V1. So what will I do to the other sources?
Sir, we replace the current source by open circuit.
Okay. And what about the voltage source?
By short circuit.
Okay. So your current sources, you replace it by an open
Current source is open circuit with their internal resistance.
Yeah, which ideally is infinite.
Yes, sir. Ideal infinite.
And voltage source, you replace it by a short circuit.
Yes, sir.
Okay. So, any doubts in this part?
No, sir.
Students there. Okay. So now we will what does Tellegen's theorem say?
Sir, Tellegen's theorem says that there is a power balance. Voltage of one product of the voltage of if the topology are same, if the circuit has same topology, then power across across the section one circuit A can be found by that voltage, that particular one branch voltage into same topology, तो same branch में जो current secondary में है product of the that current plus product, so all the product of the voltages
so
must be equal to 0.
Yeah. So it means like, suppose there is one network like this. It's represented by some graph. Okay. This is your V1, this is your I1, this is your V2, your I2, this is your V3, this is your I3, etc. Some things are there. And you have another network of the same type. Okay.
Yes, sir.
This instead is plus minus V1 prime. This is I1 prime. This plus minus V2 prime, I2 prime, etc. We do that. We can do for all the elements. So we have V1 into I1 prime plus V2
I1 dash
into I2 dash.
I2 dash.
And then the summation of something like this is equal to V1 prime into I1 plus V2 dash to I2 and the summation.
Into I2. Yes.
Okay?
Yes,
this
sir.
Tellegen theorem. Now,
Yes, sir.
Tellegen theorem will come into use when we have certain types of two-port networks. So if you have a network like this, this is your voltage, this is your current, this is also your voltage, this is your current. Okay, this is a linear network. Similarly, we have a same network or a similar network of the same topology. And this is your V1 dash and this is your I1 dash. And this is your V2 dash and this is your I2 dash. Okay, so if I want to apply Tellegen's theorem over here, so when you apply Tellegen's theorem over here, what you will get is V1 into
V1 into I1 dash
plus V2 into I2
V2
dash
into I2 dash
is equal to V1 dash into I1
V1 dash into I1 plus V2 dash into I2.
I2. Okay. We'll go to next page. Okay. So there is a linear passive network and there's a same linear passive network. If it is a linear network, passive network, and it is the same thing, then we can apply Tellegen's theorem. Okay. So in this question, we will apply Tellegen's theorem. So now when we will apply, what is V1T?
V1T equal to?
Oh, V1T is equal to what?
I1T into circuit impedance 10 UT.
It is given in the question, it is 10 UT. Okay. So can anyone tell me how will this function look as a actual symbol in your network? What is this actually? Huh?
So it's a unit step function.
Yeah, it is a step function. If you draw it, it will look something like this. This is your V1 of t. This is your time. Okay. So this is similar to your battery of plus minus 10 volt. Right? No? Your battery gives 10 volt throughout through all of time. And we are considering from time t equal to 0. So DC voltage is represented by unit step. Okay. So V1 of t is 10 UT. Now what is the Laplace transform of this? What is V1 of S?
10 by S.
10 by 8.
Yes, it is 10 by S. Now, what is I11 of t? What is I11 of t given?
2 into e power minus t u of t.
Yeah, I1 of t is 2 into e to the power minus t u of t. So what is I11 of S?
2 by 1 plus t. Sorry, 1 plus S.
Okay. Now what is I12 of t?
1 into e power minus t u of t, sir.
Okay. So what is I12 of S?
1 by 1 plus S.
So this is 1 by 1 plus S.
Yes.
Okay. Can you tell what is V12 of t?
V12 of t. V12 of t. 5 e power minus t u of t, sir.
Sorry?
5 e power minus t u of t, sir.
By
5 e power minus t, sir.
5.
Yes, sir. 5.
Achha. But why 5 it is? What is V1? What is V12 of t? Oh, I haven't written like this, right? Achha. Okay, yeah, let me see. This is V1t. Let us assume this voltage over here. This is V12 of t. Okay. So what is this
Yes,
V12
sir.
of t? What is the value of this voltage?
0, sir. 0,
Yeah,
sir.
it is 0. Okay. So what is V12 of S?
It is also 0, sir.
Okay. Next, there is some voltage V21 of t. What is that? What is the expression of this voltage?
It is I into R. That
Okay, what is that?
means I12 y I21
I21.
8, sir.
So this is 8 into I21t, right?
21 of t.
Okay. So now, also we know that we don't know I21 of t. We have to find out I21 of t.
Yes, sir. Yes, sir.
And there, what is V2 of t?
V2 of t is given, sir. 5 e power minus t u of t, sir.
Okay, so what is V2 of s?
5 by 1 plus s.
5 by 1 plus s. Now I have to apply Tellegen's theorem to this. What will be the expression? So it will be V1 of t into current which is going out. It will be a current which is going out. So that will be minus I21 of t. Okay. Plus V12 of t into the current which is coming in like this. Okay, the current which is coming in. So this current, let me call it I22t. So V12 of t into I22t. This should be equal to this voltage in this side, that is V21 of t into the current that is coming out, that is I11 of t plus V2 of t into I12 of t. No, into minus of I12 of t. Is it clear? So I'm doing V1 of t into the current which is going inside, that is minus I21 of t. So this is one expression. Then V12 of t, that is the voltage.
Sir.
Tell.
Sir, we take that the current is incoming. That's why we take I21 is minus.
Yeah, yes. Current should be entering the network. Okay, it should be entering. It should be going in, going in. That is the convention I'm using.
Yes, sir.
Sir, current entering means positive, sir.
Yeah, if current is entering, it is positive.
Okay, sir.
Over here, it is going out. So that's why I made it negative. So V1 of t into minus I21 of t plus V12 of t into I22 of t, that is this current, is equal to V21 of t. What is V21 of t? That is this voltage, V1 of t into I11 of t, current which is entering, plus V2 of t, that is this voltage, into current which is entering. This is the current which is entering, minus of I12 of t, because I12 of t is going out. Okay, so till here, any doubts?
No, sir. No, sir.
No, right? Okay, so now what is V12 of t?
That's I21t into 8. V21t equal to I21t into 8.
I asked V12t. V12t.
1 to 2 is 1 by 1 plus s.
V12t is 1.
sorry. V12T. V12T is 0.
Yeah.
Circuit is short circuit.
Yes. Okay, it is 0. So we get it as, so this part becomes 0. So we get minus V1T into I21 of T is equal to V21 of T into I11 of T minus V2 of T into I12 of T.
1 of 3.
Yes. So now we'll take the Laplace transform. So we'll get V1 of S into I21 of S is equal to V21 of S into I11 of S minus V2 of T into I12 of T. Okay. So now we'll substitute. What is V1 of S? V1 of S is
10 by 8.
So this is minus 10 by S. What is I21 of S?
Does not give answer.
Yeah, so we have to find I21 of S. Okay, what is V21 of S?
V21 of S is 8 into I21 of S.
This is 8 into I21 of S. What is I11 of S?
2 by 1 plus S.
2 by S plus 1. What is V2 of S?
5 by 1 plus S.
5 by S plus 1. What is I12 of S?
1 by 1 plus S.
1 by 1 plus S. Okay. So now, we will take this term to this side and we will take this term to this side. So we will get 5 by S plus 1 into S plus 1 is equal to 16 of I21 of S upon S plus 1 plus 10 upon S into I21 of S. Is this part clear? Hmm?
16.
Yes, sir.
Yes, sir. Yes, sir. 16 into T plus 1. Yes, sir. Yes, sir.
This becomes 5 upon S plus 1 the whole square is I21 of S into 16 upon S plus 1 plus 10 upon S. So that becomes 5 upon S plus 1 into S plus 1 is equal to I21 of S into 16 upon S plus 10 into S plus 1. I am doing cross multiplying. Okay. To S into S plus 1. Is this clear?
Yes, sir.
So this S plus 1 and this S plus 1 gets cancelled. So we have 5 upon S plus 1 is equal to I21 of S into 26S plus 10 upon S. Okay.
Yes, sir.
So I21 of S is equal to 5 into S upon S plus 1 into 26S plus 10. or it is equal to 5 by 26s upon s plus 1 into s plus 10 upon 26. Is this clear?
Yes, sir. Yes, sir.
So now how will we solve this?
By partial fraction.
Partial fraction, sir.
Okay, by partial fractions. So what I will do? I will write 5 by 26 s upon s plus 1 into s plus 10 by 26. This is equal to
A by s plus 1
plus 1 plus b upon s plus 10 upon 26. Okay. So when you cross multiply, you will get 5s upon 26 into s plus 1 into s plus 10 upon 26 is equal to a into s plus 10 upon 26 plus b into s plus 1 upon s plus 1 into s plus 10 upon 26. So what we can cancel? And this also we can cancel. So we get 5s upon 26 is equal to a into s plus 10 upon 26 plus b into s plus 1. Okay, so now I want to find the values of a and b. So if I want to find the value of a, what will I put s?
is equal to minus 1.
Minus 10 upon 20.
We put s is equal to minus 1. So we get 5 into minus 1 upon 26 is equal to a into minus 1 plus 10 upon 26 plus b into 0. That's how we eliminate b. So we get minus 5 upon 26 is equal to a into minus 26 plus 10 upon 26. That is equal to a into minus 16 upon 26. So what we have? 5 upon 26 is equal to a into 16 upon 26. This implies my a is actually equal to 5 by 16. Any doubts in this?
No, sir.
Okay, now, sorry,
Yes, sir.
someone is saying something?
No, sir. No, sir.
Okay. Now I want to find B.
B
So for S, I will put what?
minus 10 by 26.
Okay, so for B, minus 10 by 26. So we get 5 upon 26 into minus 10 upon 26 is equal to A into 0 plus B into S plus 1. That becomes minus 50 upon 26 into 26 is equal to B minus 10 plus 26 upon 26. That becomes minus 50 upon 26 is equal to B into plus 16. So we get B is equal to 50 minus 50 divided by 26 into 16. That comes out to be how much?
Because of 25 into 13 divided by 25 by 208.
Okay, the actual value
0.12.
minus 0.12019. Okay.
Sir, minus can.
How?
1 minus. Yes, sir, minus.
Minus.
Yes, sir, minus.
Will be minus only, right?
Yes, sir.
So we get I to 1 of S is equal to A. A is equal to 5 by 16. What is 5 by 16?
0.3125, sir.
Yes. 0.3125. So it will be 0.3125 upon S minus 0.12019 divided by S plus 10 upon 26. Now, what will I to 1 of T be then?
-0.3125 minus 0.1
into e to the power minus t.
e power minus 10 by 26 t.
And this will be
10 divided by 26
u of t
is sir into u of t, sir.
Yeah. Okay.
Sir,
So
0.312 s into e to the power minus t.
why?
There is s plus 1. S plus 1. A by s plus 1. Na?
Oh, A by S plus 1. Sorry.
A by s plus 1. Na, sir.
Okay. So this will be
Yes, sir. E power minus t, sir.
E to the power minus t. 0.3125 into e to the power minus t.
okay. Right?
Yes, sir.
Yes, sir.
Okay. So any doubts in this?
No, sir.
Yeah. So I'm having Zoom meetings. So these Zoom meetings end in 40 minutes. All right. So every 40 minutes it will
Yes,
end.
sir.
Then I'll again restart this meeting and you can again join. I'll
Yes,
also
sir. Yes, sir.
add the links actually. Just hold on. So this is my channel link and drive link. So, added it. So I'm pasting it in the chat. So channel link is the YouTube link where I will, after the recording, I will merge the videos and I will edit and I will upload the videos there. And drive link is where I will upload the notes. These notes will be converted into PDF and uploaded on the drive. All right.
Yes, sir.
Yes, sir. Yes, sir.
Okay. So now we will proceed to the next question. Okay. So in this, so can you read the question once? I'll give you 1 minute to read the question. So how will we solve this circuit? Or what is the network given to us? So you see there is
Norton's theorem. Sir, we are applying the Norton's theorem, we can solve. By short circuiting the AB terminal, we get the short circuit current, and across the AB terminal, we get the resistance RAB, Thevenin's equivalent resistance, 5 ohm.
5 ohm.
5 ohm, Thevenin's resistance across AB terminal, load terminal, given RAB equal to 5 ohm.
Okay. So here you don't have resistor, you don't know how much is a capacitor, all this you don't know. So with whatever expressions is given to us, we have to proceed. Okay. So now we proceed. So we don't know what is a resistor, we don't know what is the capacitor. All we know is they have told us that the open circuit voltage between A and B is given by this expression, phi into 1 minus e raised to minus t upon phi u of t. Okay. And they told that if I short terminals A and B, then the short circuit current from A to B is given by phi u of t ampere. So to solve this, what can we do? So one theorem is there that is known as the Thevenin's theorem. What does Thevenin's theorem state?
Every circuit is modified into Thevenin's voltage source in series with equivalent Thevenin's impedance in series with load resistance.
Okay. So now in our question, what is the load resistance?
Load resistance is given, sir, 5 ohms, sir.
So my load is given, that is RAB, that is 5 ohm. What is my open circuit voltage or Thevenin voltage?
VAB, sir.
Okay, that is phi into 1 minus e raised to minus t upon phi u of t. What is my Z Thevenin?
ZTH VAB by IAB, sir.
To find Z Thevenin, what they do, you have the open circuit voltage, you have the short circuit current, you divide them, that is your Z Thevenin. Okay. So.
Okay, sir. Okay, sir.
So your I short circuit is phi u of t. So now we will find the. So now how you will proceed? You will do VTH upon ISC, and what will you get? Can you apply it like this? Phi into 1 minus e raised to minus t upon phi divided by phi u of t. Can you do it?
No, sir.
Put it in a Laplace domain.
Laplace, sir.
You have to convert it to Laplace domain. So what is VTH of S in Laplace domain?
5 by S minus 5.
5 by?
5 by S minus 5.
S plus 5, sir.
S plus 5, yes.
S plus?
5, sir.
5.
What about others?
1 by 5. 1 by 5.
You said 1 by 5? Okay, it is S plus 1 by 5. Okay. So 5 by S plus 1 by 5. Because it's in denominator, right?
Oh, okay, sir. Okay, sir.
So now you have to take you cross multiply. So it becomes 5 by S plus 1 by 5 minus 5 into S upon S into S plus 1 upon 5. Okay. So that becomes equal to VTH of S is equal to phi S plus 1 minus phi S upon S into S plus 1 by 5. That is equal to 1 by S into S plus 1 upon 5. Okay, what is SC of S?
Pi by S, sir.
Pi by S. What is my Z Thevenin of S?
VTH by IST.
Yes. Okay, who's using a washing machine? Someone is making noise. So we get it to be equal to 1 by S into S plus 1 by 5 divided by 5 by S. So your S and S get cancelled. So it becomes 1 by 5 into S plus 1 upon 5. Okay, this is your ZTH of S. So
Yes, sir.
now we know by Thevenin's theorem, we have our VTH of S. Then we have our ZTH of S. Then we have our Z load. Okay, which is equal to how much? How many ohms?
10 ohms, sir. 10 ohms,
5
no, sir. 5 ohms. 5 ohms.
5 ohms. What is ZTH of S? Is equal to 1 by 5 into S plus 5. So this is equal to 1 by 5 into S plus 1 by 5. And VTH of S is equal to 1 by S into S plus 1 by 5. So this is equal to 1 by S into S plus 1 by 5. And what have they asked in the question? They have to find the current. So we have VTH of S is 1 by S into S plus 1 by 5. Okay. And ZTH of S is 1 by 5 into S plus 1 by 5. So we have this current. What is this current given by? I load. What is the expression? Hello? Karya, Bharat, Kumar Reddy. What is I load?
Sir, VTH of S, VTH
Sir,
of
sir.
S divided by
Okay.
ZT of S plus ZL.
Sir, VTH by ZTH plus ZL, sir.
Okay. So this is 1 by S upon S plus 1 by 5. This is 1 by 5 into S plus 1 by 5 plus 5. Okay. So my I load of S is equal to 1 by S into S plus 1 by 5. This 1 by 5 S plus 1 by 5 cross multiply, so it becomes 1 plus 5 into 5 into S plus 1 by 5 divided throughout by 5 into S plus 1 by 5. Is this step clear?
Yes, sir.
So this S plus 1 by 5 and S plus 1 by 5 gets cancelled, and this 5 goes to the numerator. It becomes equal to 5 by S divided by 1 plus 25 into S plus 1 upon 5. Okay. So that becomes equal to 5 upon S, 1 plus 25S plus 5. So that is equal to 5 by S, 25S plus 6. That is equal to 5 by S into 25S plus 6 that is equal to I load of S is equal to 5 divided by 25 S into S plus 6 upon 25. So that is equal to 0.2 upon S into S plus 6 upon 25. Is this part clear?
Yes, sir.
Yeah. So we'll add another page. So we get I load of S. Now how will we solve this? Bharat, how will we solve this?
So break
Yeah,
into
partial
partial fractions.
We have to do partial fractions. Okay, partial fractions. So this 0.2 upon S into S plus 6 upon 25. We write it as equal to A upon S plus B upon S plus 6 upon 25. Okay. So when we cross multiply, we get 0.2 upon S into S plus 6 upon 25 is equal to A into S plus 6 upon 25 plus B into S divided by S into S plus 6 upon 25. Okay. So now these are get cut. So 0.2 is equal to A into S plus 6 upon 25 plus B into S. So to find A, what do we put S to be?
0.
S is equal to 0, sir.
So we get S equal to 0. So we get 0.2 can be written as 1 by 5. So this is A into 6 upon 25 plus 0. So 5 divided by 25 is 5. So we get A is equal to 5 upon 6. Any doubts here?
No, sir. No, sir.
So to find B, what should we put S to be?
Minus 6 by 25.
So we put S is equal to minus 6 upon 25. So we get 0.2 is equal to B into minus 6 upon 25. So this is 1 by 5 is equal to B into minus 6 upon 25. So your B, sorry, let me save it also. So your B will be equal to minus 5 by 6. Okay. So now you will get I load of S, that is A upon S, that is 5 by 6 upon S minus 5 by 6 upon S plus 6 upon 25, right? So when you find the Laplace inverse, what will you get?
5 by 6 minus minus 5 by 6 e power minus
E to the
6 by 25 t
upon 22 t into U
yes,
of
sir. Into u of t. Sir.
Okay.
Yes, sir.
So that's how in this circuit you should know Laplace transforms, and partial fractions also is very important. Okay.
Yes, sir.
Now there's a shortcut. So let me just ask all of you guys. So Shubhaka Mohta, like you're currently, what are you doing? You're planning to give gate?
Yes, sir. Yes, sir.
Okay, what about Kavya?
Yes.
I didn't hear. Okay, what about Akash and all? Akash,
Yes, sir. Yes, sir. We planning to do.
okay. And Bharat and Kumar,
Sir, preparing for R-set, sir.
what is that?
R-set, sir. Reset set, sir. State-wise, sir.
Okay.
Yes.
Okay. And then Mia Farhan, I'm seeing you for the first time. And Narasimha Inamdar.
Yes, sir.
So you are a student?
Hi, sir. I'm a student. Final year, sir.
Okay, final year BTech. Okay. You are planning to give GATE. Oh yeah, what
Sir, like I tried. Already gave my first attempt recently.
Okay. And what about R. Suresh Babu? Huh? Okay, so some of you are not answering. Okay, so I'll just assume that many of you are interested in GATE exam. So there is a simple trick when you have to solve partial fractions. Assume you have some number. Assume some number. Suppose you have k upon s plus a into s plus b. You have to find it out to be a upon s plus a plus b upon s plus b, right? So now you do the whole entire step and everything. It will be time consuming. So what I do is, there's a simple way is, first I write it down as k into 1 upon s plus a into s plus b. This is, I find the partial fractions for this. Okay. So that will be equal to some k into a dash s plus a plus b dash into s plus b, where a is equal to k into a dash and b is equal to k into b dash. Okay. Any doubts in this?
Yes, sir. No, sir.
No, sir. Yes.
Now I'm going to focus on this, right? I want to focus on this. So I'm going to focus on 1 upon s plus a into s plus b. I'm going to write the partial fraction of it. So what I do is I do 1 upon s plus a minus 1 upon s plus b. So now this, okay, this has to be
Yes, sir.
multiplied by some value. Okay, by some value. Let us assume that value is some m. Okay, now I want to find out what is this value. And why I'm saying that, let me tell you. If you do this, if you cross multiply, let us cross multiply. Okay, so this becomes equal to, so we have 1 upon s plus a into s plus b is equal to s plus b minus s plus a upon s plus a into s plus b into m. So this is equal to 1 by s plus a into s plus b is equal to b minus a upon s plus a into s plus b into m. Because your s and s get cancelled. Okay.
Yes, sir.
So now if you want your left hand side to be equal to your right hand side, then what should be the value of m?
One by b
1 by
minus.
b minus a, sir.
So m should be equal to 1 upon b minus a. Okay. So if your m is equal to 1 by b minus a, then you can write this as, so this you will replace by this. Okay, sorry. So this you will replace by this. Okay, so you will get 1 by s plus a into s plus b actually is 1 upon b minus a into 1 upon s plus a minus 1 upon s plus b. Okay. This is a shortcut.
Yes, sir.
This is a This is something I like to use. Find it to be very useful. Okay. But
Yes, sir.
you are not finished solving because you have your actual expression is what? K upon S plus A into S plus B. So your result will be equal to K upon B minus A into 1 upon S plus A minus 1 upon S plus B. Okay.
Yes, sir.
So very
Yes,
quickly,
sir.
by just seeing, if I just see S plus A into S plus B something, I can directly write it in this form very fast. I don't need to spend my time solving. Now let us consider for our expression which we got. What did we get? We have 0.2 upon S plus 6 upon 25. So, okay. So we have 0.2 upon S into S plus 6 upon 25. So what is our K? What is K in our case?
A 0.2.
0.2, sir.
So our K is 0.2. What is my A?
1. 8 0.
0, sir.
A is 0. What is my
A
B?
0.
6 by
6 by
25, sir.
20.
So now let us put over here. So this is actually equal to 0.2 upon B, that is 6 upon 25 into 1 upon S plus A, that is S, minus 1 upon S plus 6 upon 25, right? So that is equal to 0.2 can be written as 1 by 5, 6 upon 25, 1 by S minus 1 upon S plus 6 upon 25. Okay. So 25 and 5 becomes 1 by 5. So it becomes equal to 5 by 6 into 1 by S minus 1 upon S plus 6 upon 25, which is what we had got earlier. If you remember, this 5 by 6x minus 5 by 6s plus 6 upon 25, we can write it down as 5 by 6 into 1 by S minus 1 upon S plus 6 upon 25. Okay?
Yes, sir. Okay,
Yes,
sir. I
sir.
got it.
Yes, sir.
So this is a shortcut. So like I remember when we practice for JE or JE Advanced, all that, they'll have some shortcuts. And if this is your type of sum, this is the shortcut, this is the shortcut formula, you must use it. So at that time in my life, I was like, okay, these are the shortcuts, everything. But later on, I realized like we must learn how to derive these shortcuts. So once you derive this shortcut, then you have confidence that this will work all the time. Then whenever you see a sum, you can just directly use the shortcut. Okay.
Okay, sir. Okay, sir.
So, and see, when you solve sums, first of all, it is very important that you must solve it on your own without seeing any solution. So now I upload this notes. This notes is not for you to directly see and solve. You have to open the question and see the question alone and solve it by yourself. Then if you have made a mistake, then, and if you're not getting the correct answer, then you come and refer to my notes and find out where you have made the mistake. And maths is something, or like maths, because this is basically in electrical engineering, we have lots of maths. Maths is something which you can only become good at if you practice it. And one thing I found very useful, which my teachers had taught me, is whenever you use a formula, you write it down. You write down the formula. Like we know that any formula, like, a plus b the whole square is equal to a square plus 2ab plus b square, right? So whenever you're using this formula, you write down that a plus b the whole square is equal to a square plus 2ab plus b square. Each time you use this formula, you have to write down that formula. So when you do that, you will memorize that formula. It will become part of you. So once you practice consistently, you will know this formula is this. And then when you give GATE exam, you don't need to write the formula like this. That time you can just directly solve. But while you are practicing and learning, that time you must, each and every time you use a formula, you write down that formula. So that's something which has worked for me. So if you guys also can try it while solving sums.
Yes, sir. Thanks, sir.
Yes.
So now let us go to next sum. So this is the sum. Okay. This is the question. Okay, so we have to use compensation theorem. Okay, we have to use compensation theorem for this. So what is compensation theorem? Does anyone know?
No, sir.
No. No one knows. Sir taught, right?
No, sir. I tell about the Tellegen theorem and reciprocal theorem.
Oh, this wasn't taught.
No, sir.
Okay.
No, sir. Don't know, sir.
Okay. Okay, fine. So we'll try see compensation theorem. Okay. So you have a network. Okay, you have a linear network. Linear passive network. Okay. This is your V1. This is your V2. This is your I1. This is your I2. This is your Z. This is your I. Okay, so what do you mean by linear network?
The network consists of the linear elements.
Okay, so so is a capacitor linear element?
Resistor, inductor, capacitor are the linear element.
Okay. Okay. What do you mean by passive network?
Passive means those network don't with its whose own energy source.
Okay, so now that means we have a network in that all these voltage sources etc. are external. Okay? There in this network it only consists of resistor, inductor, capacitor. All right. So now what happens when this Z gets changed to delta Z? My Z gets converted to delta Z. When that happens, what will happen? My current I will become delta I plus delta I. So to understand how will we solve such a network, we use compensation theorem.
Yes, sir. Yes, sir.
Now, what will we do is, do you guys know what is substitution theorem?
Yes, sir.
What is that?
In substitution theorem, we can replace any source to any branch. Same current will flow.
So substitution theorem means that if you have some current and if you have some impedance Z1, we can replace it by a voltage source I into Z1. Okay. Into an equivalent voltage source in our network, and it will be the same. So what we do over here is we have the same linear passive network. V1 all these voltage sources, I1, I2. We replace this I plus delta I and Z plus delta Z by what? We replace it by plus or minus IZ plus or minus delta I into Z plus delta Z plus or minus I delta Z. Is this clear? So this I plus delta I into Z plus delta Z is replaced by IZ delta I into Z plus delta Z plus or minus I into delta Z. Any questions in this?
No, sir.
Delta.
We just multiplied it. And this one we left as it is. Okay. So now, what is our original network? What is our original network? What is my original network? It is linear passive network. It has my V1, V2, I1, I2 into I into Z, or that we replace it by plus minus I into Z. Right? Is this correct? This was my original network.
Yes, sir.
Yes, sir. Yes, sir.
So now, here if we apply superposition theorem, over here the current is actually I plus delta I, right? I plus delta I. But over here, the current is just I. Now, what will happen is so this is the current here is just originally I. But in our new network, the current is I plus delta I. So if we want to apply superposition theorem, then what is the change? Now I want to apply superposition theorem. So if I apply superposition theorem, what will happen to my voltage sources and current sources? Excuse me.
Voltage short circuited, current open circuited.
Yes. So these are replaced by the internal resistances, right? So now I will get my linear passive network. This is short circuited, this is short circuited, this is open circuited, this is open circuited. And what will be the current over here? Will it be I or will it be delta I?
Delta I, sir.
So this will be delta I, and here this voltage is the voltage over
I
here.
delta Z.
I delta Z, correct? I delta Z, and over here it will be Z plus delta Z.
Delta Z.
So, is this clear? So let me go over again. This is considered, this is A. This is A. Voltage source is short circuited. Current source is open circuited. Current over here is delta I. This voltage is plus minus I delta Z. This is Z plus delta Z. Consider circuit B. This is circuit B. Current here is I. Voltage here is plus minus IZ. These are the voltage sources. These are the current sources. Now, when you add A and B, you do superposition of A and B. You will get this circuit. Voltage sources are still present. Current sources are still present. The current here is I plus delta I. Right? Current here is I plus delta I. And the voltage over here is plus minus IZ. Plus minus delta I into Z plus delta Z. This is equivalent to your Z plus delta Z into your delta I, which is flowing. And this is plus minus I into delta Z. Is this clear? So this is your circuit C. Okay. So I'll repeat once more. This is my linear passive network. So it consists of just passive elements and your voltage sources, current sources, etc. They are present. There is one impedance Z. One impedance Z is there. It gets changed by some value delta Z. So if this impedance has changed, then your current also has to change. So it becomes delta I. Now we decompose this into two parts. One is the original network. This was your original network. V1, V2 is there, I1, I2 is there, your current. Same current I is flowing. And instead of that impedance Z, I replace it by a voltage source plus minus IZ. And this comes by substitution theorem. Substitution theorem states that an impedance can be replaced by a voltage source of magnitude I into Z. So that I have replaced over here. Now, and this is the actual final network. This is my actual final network. V1, V2, I1, I2, I plus delta I. So this is IZ, delta I into Z plus delta Z, and I into delta Z. So to get this network, from this network, the network which I'll have to make, network which will come is this. This is the network which you will get. You will have delta I flowing here and Z plus delta Z. And the voltage over here will be plus minus I delta Z. Right?
Yes, sir.
Okay, so we will use this concept for solving the next sum. So you guys are able to see my screen?
Yes, sir. Yes, sir.
Yeah.
Okay. So we will go to the question. Okay, so this is my question. So what have they given us? They have given I1 is equal to 8 ampere, I2 is equal to 9 ampere, your R is 20 ohm, E1, E2 is not given to us. Now this told R new is equal to 35 ohm. So we have, and this is R old. We write this as R old. So what is delta R? Delta R is R new minus R old. How much is that?
15, sir.
So that is 15 ohm. Okay. Now we have to apply compensation theorem. Okay, what is I3 over here? What is I3? What is the value of I3?
I1 plus I2.
What is I1 plus I2?
7.
So this is I1 plus I2 is equal to 17. Okay. So now when I will change now this R over here, this R has become R plus delta R. When this has become R plus delta R, this will become I3 plus delta I3. So I need to find out what is this delta I3. I need to find out. Delta R has been given to me. We have found it. So now by compensation theorem, I can use this network. And if I want to use this network, what will happen to the voltage sources?
Short circuit.
Short circuited.
Short circuited.
They are replaced by short circuit.
And currents open circuits.
Yes. So now here there are no current sources. They are just voltage sources. So it will become 10 ohm here, 10 ohm here. Okay. This is your delta I3, right? This is equal to I into delta Z. So this is equal to I3 into delta R, and this will be equal to your R plus delta R. Okay. This is your network. So we will further solve it. This can be written as 10 delta I3. What is I3 into delta R?
17 into 20.
255
17 into
volts.
15, sir.
17 into 15. Where's my calculator?
255
17 into
volts.
15, sir.
Okay, 255. And what is R plus delta R?
35, sir.
So this is 35. So what is my delta I3?
$255 divided by 40.
This is 255. So if this is the voltage source, my delta I3 will be negative. So this is minus 255 divided by 35 plus 10 parallel 10, that is 5 plus 10 parallel 10. So my delta I3, see, my voltage source is giving some current Ix. Okay, this is Ix, which is equal to minus delta I3. So that is minus 255 divided by 35 plus 10 parallel 10. So my delta I3 is equal to minus 255 divided by 40. How much is that?
Minus 6.375.
6.37.
Minus 6.375 ampere. Okay. Now, this is my delta I1. This is my delta I2. So from delta I3, what is delta I1? How much is delta I1?
Apply current
Using
divided
current division rule, sir.
How much it will be?
3.1875
Correct.
minus 3.187.
So my delta I1 is equal to delta I2, which is equal to delta I3 into 10
Divided by
upon 10 plus 10. So that is equal to delta I3 divided by 2. That is equal to minus 3.1875. Is this clear?
Yes, sir.
Any doubts here?
Yes, sir.
Okay, Uta doesn't have any doubts? Not there. Okay. So what is my I1, final I1? What is my I1 new? Is I1 old plus delta I1. My I1 old was 8. Delta I1 is minus 3.1875. This is how much?
4.8125.
Huh?
4.8125, sir.
So
4.8125, sir.
4.25 ampere. What is I2 new?
5.8125.
Okay. So that is 9 minus 3.1875. That is 5.8125 ampere. What is I3 new?
10.625, sir.
Okay. So you guys are so fast calculating.
Using calci, sir.
Okay, very good, very good. Yeah, but try to minimize calculator usage. Huh? To be helpful.
Yes, sir.
So this will be equal to 5. So 10.625 ampere, right?
Yes, sir. Yes, sir.
Okay. So any queries in this compensation theorem? So this is done. We go to the final question. Okay. So can everyone see this question?
Yes, sir.
Okay. So what do you think is the challenge in solving this question, or how we must proceed in solving this question? Huh?
No idea, sir.
No idea. Means it is a very difficult question.
Yes, sir. Looking like
No, sir.
difficult, sir.
Kavya, nothing is difficult. Okay.
Sir,
So
because the frequency is given, so
Come-
capacitor frequency we can.
so you start with what was given. You are given frequency 60 hertz.
Okay, sir.
So now you can find the capacitive reactance. So what will be the capacitive reactance for 100 microfarad? What will be the value?
$26.525, sir.
Yes. So that will be equal to, it is actually given by 1 by j 2 pi f into
Yes, sir.
c
Minus J 26.525, sir.
is equal to minus j 26.525 ohm.
525.
Yes,
Okay.
sir.
So
Yes, sir.
similarly for in the 25 microfarad case, what will it be?
106.103.
How much?
106.103.
Yeah. So it will be 106.103 ohm. Okay. So this is there. Now we have to find VMN. So if you look at this circuit, will it be better to do mesh analysis or nodal analysis?
Nodal analysis, sir.
Why?
Because always nodal analysis is somewhat easy, sir.
Not always.
Always, sir. Okay, sir.
Sir, we have only 2 nodes.
Yeah, there are only 2 nodes. That is, there are only 2 nodes.
Okay.
You have only one equation. Okay.
One will be the reference, so we can calculate.
Huh?
One will be the reference, so with only
No.
one equation we can calculate.
Yes, yes. Since there are only 2 nodes, you will have only one equation. So let us assume this is your reference node. Assume this is your reference node. So you have your VMN, okay, minus 150 angle 60. I'm considering the current going out. So that will be 100 minus J 26.525. Plus I consider this current. That is VMN minus 150 angle minus 60 divided by 400 minus J, that is 106.103. Plus I'm considering this current. That is VMN minus 150 angle minus 180 divided by 100 minus J 26.525. This is equal to 0. Okay. So can anyone tell me one easy trick to solve this? Or something you have observed? No? Brother Suresh, Kumar, Akash, Mia Farhan, Narasimha.
Sir,
Yes.
denominator into 4, sir.
Yeah. What I do
Is it
is,
right, sir?
yeah. So 400 is
Okay, sir. Thanks.
and 100 is there. 106 is there, 26 is there. So this is 4 into this. So if I want to make a same denominator, common denominator, what I will do, I will multiply this by 4. I will multiply this also by 4. I multiply this by 4. I multiply this by 4. Rest all remains the same. So I get 4 into VMN minus 150 angle 60 plus VMN minus 150 angle minus 60 plus 4 into VMN minus 150 angle minus 180 divided by 400 minus J 106.103. This is equal to 0. Okay. Now what to do?
Denominator is 0, sir. Multiplying.
So if we take the denominator this side, it becomes 0.
0.
So
Yes, sir.
that means we have 4 into VMN minus 150 angle 60 plus VMN minus 150 angle minus 60 plus 4 into VMN minus 150 angle minus 180 is equal to 0. So what we'll do now, we will take all VMN common. So this will be VMN into 4 plus 1 plus 4. Then minus of 4 into 150 is how much? 600 angle 60 minus 600 angle minus 60. No. Sorry. So this is minus 4 into 150 angle 60 minus 150 angle minus 60 minus 4 into 150 angle minus 180, that is equal to 0. Okay. So I have VMN into 9 is equal to 600 angle 60 plus 150 angle minus 60 plus 600 minus 180. Is this clear?
Yes, sir.
Okay. So I get VMN into 9. What is the sum of all this?
Minus 1073.
450 at an angle 120.
Yeah. Video drive link. This will be uploaded on YouTube, Suresh. On the YouTube channel. So the link I've shared it. Share again.
Okay, sir.
This is the link. Okay, so these are links. Okay. So yeah, what is this? What is right hand side?
450 at an angle 120, sir.
450 at an angle 120. What is VMN?
50 at an angle 120.
So that is equal to 50 at an angle 120 volts. So till here, anyone has any question or anything?
Sir, one doubt, sir.
Sir,
How is 450 at an angle 120, sir?
When we add the phases. So
Yes.
if you have calculator, you can do it. Like
Yes, sir.
we have to go to the complex mode.
Yes, sir.
But in GATE exam, I don't think you have this option. Then
Yes, sir. Yes, sir.
you decompose
sir,
it into,
manually how we can do it?
okay, so manually. So your 600 angle 60 is actually 600 into e raised to 60. Oh no, JT raised to J60. So that is actually equal to 600 into cos of 60 plus J sine of 60.
Sine 60.
So what is 600 cos 60? So that is 600
300.
into half plus J
Yes, sir.
root 3 upon 2. So that is equal to 300 plus what is 300 into root 3 by 2?
519.
519.6, sir.
So 519.
590.6, sir.
Okay, fine. Now it's similarly a 150 angle minus 60 is equal to 150 into cos of minus 60 plus J sine of minus 60. So that is 150 into half minus j root 3 by 2. So that is equal to 75 minus root 3 by 2 into 150. That is minus j 129.
129.9, sir.
Similarly, what is your 150 angle minus 180? That is equal to your 150 into cos of minus 180 plus j sine of minus 180. That is equal to your 150 into minus 1 plus j0. That is equal to minus 150. Okay, it is wrong. This is 600. Is this clear?
Yes, sir. Yes, sir.
So then you add it. You add 600 angle 60 plus 150 angle minus 60 plus 600 angle minus 180. If you add it, what do you get? Let me zoom out for you guys. What is 300 plus 75 minus 600? So you add the real
Minus
part.
225.
Huh?
Minus 225, sir.
It is minus 225. And what is the imaginary part?
$389.7, sir.
That is 389.715.
0.7.
Okay. So all this is equal to 9 into VMN. So this actually is 9 into VMN is actually equal to minus 225 plus J 389.75. Right? Now, how do you convert this into your original form? Into this form. If you want to convert it in this form, what will you do? So, you have to find out. You have to find a polar representation. Suppose you have numbers a plus bj that you represent it as r angle theta, right? This is
Yes,
your
sir.
complex number. You represent it as r angle theta. What is your r?
Square root of a square plus b
Square
square,
root
sir.
of
Okay. What is your theta?
X square plus
Tan
tan of
inverse
b
b
by
by
a.
a.
Tan inverse of b by a. So in this case, what is your r?
Square root of 125 square plus
450, sir.
225 square. 225 square.
25 square.
So,
It will be 450.
so that is 450. What is your theta? This is interesting. What is theta?
120.
Huh? How much is your theta? Sorry?
minus 6,
Minus?
60.
Theta is minus 60.
Yes, sir.
Okay, so our answer which we get is 9 VMN is equal to 450 angle minus 60. So your VMN is how much?
50 at an angle minus
50
60.
and then
50 at an angle minus 60, sir.
Okay, but what was the answer you got? You got
450 at
50
an angle
angle
120.
120. So where is the error? So
Sir, it's the representation.
yeah, the representation. So R
Like,
is correct. Your theta is wrong.
yes, sir. Tan theta, it will be same for at minus 60 and 120 degrees.
Okay, then how will I know which one to take? Because if you see your polar plot, if you see this is your plot. Minus 60 is this. This is a minus 60. And 120 is this. This is 120. So am I at this point or am I at this point? How will I know?
Sir, depending upon sign of A and B, sir.
Yes. So now this is your A, this is your B, this length is your R, this length is your R. So which one is, so R you got it to be 450. Now you want to know is it this theta 1 or this is your theta 2? Which one is your correct theta? So now what is your A? Your A is minus 225. Your A is minus 225. Your B is 389.75.
389.7.
Okay. That means where is your A? A will be where? Over here somewhere. And your B is
Yes,
where?
sir.
Over here somewhere. So the effective resultant is over here. Okay.
Yes, sir.
That means your angle should be 120. Right?
Yes, sir.
But when we solve, you must keep into consideration if your A is negative, by chance if your A is negative, then to whatever answer you get, you add by 180 plus whatever theta you get. So when what you do, you just theta is tan inverse of B upon A. You get some value. And in case your A is negative, you add 180 to that. It is as simple as that. So what you got? You got theta is minus 60. I add 180 to it, I will get 120. That is all is to be done.
Yes, sir. Yes, sir. Thanks.
Yes, sir.
Any queries in this?
No, sir.
So actually, in electrical engineering, you have to use maths. There's no escape from it. So this foundation of your trigonometry, sine, cosine, all that is important. So you know, right? Here everything is positive. Here sine is positive. Here tan is positive. Here cosine is positive. All silver teacups. That is a way to remember. Right?
Yes, sir.
So you guys are okay. So some of you are in final year, some of you are preparing for exams. So these things you cannot escape if you want to do electrical engineering well. No, you cannot escape.
Sir,
Huh.
sir, what is the textbook we have to follow, sir, for this network analysis, sir?
I actually don't remember. Like I studied many years back. So and in my college, basically the teacher will give some sums and we will solve assignments, everything. So
Mm.
I didn't actually like my
Because
one.
I referred so many textbooks, sir, but I don't found this problem, sir.
Okay. Of course.
Like Van Valkenburg,
Okay.
Sadhuku, and William Height,
Achha.
Sudhakar Shyam all I
Mm,
referred, sir, but this model is not there, sir, anyway.
oh. So like I also when I studied, if at all I took a textbook also, those sums used to be much simpler than the sums which my teachers used to give. So
Hmm.
finally, if I wanted to pass and everything, I had to do the sums which my teachers used to give. So I actually don't know from where my teacher used to take those sums also. So we students would like to know na, from which textbook the teacher is taking sums so that you practice and you can get marks. But that time we were not able to identify from where she took this.
Yes, sir.
Yeah.
Okay, sir. Thanks, sir.
But like these NPTEL things you can try, the NPTEL
Hmm.
questions, everything.
Yes, sir.
Yeah. And anyway, after the assignment also your solution is being provided to you guys, right?
Ah, yes, sir. Yes. Okay, sir.
Yeah. So that's it. Okay. Then okay, so any other doubts anyone has in how to solve
No, sir.
others?
Can we quickly see the problem number one?
Which one?
Problem number one, first problem.
Okay, problem one. Okay. So
No, actually, yeah.
yes. So this is a linear passive network, and for this case, we can use Tellegen's theorem. It can be used. So we have V1 into this current plus this into this current should be equal to this voltage into this current plus this voltage into this current. Based on that, we have solved. So, Bharat, like any specific part in this which you are finding confusing or anything? Hello. Bharat?
I think it is Suresh who asked to.
Uh-huh. Okay, so like V1 of S, we do it in Laplace domain, we convert it into Laplace domain, we take the Laplace transform of it. One thing is which we have to keep in mind that V1 t of t is 0. So that's why we don't need to know what is I22 of t. And the remaining thing information I11 of t, I12 of t, V2 of t, V1 of t, and this voltage also is 82 I21 of t, which we need to find out. Those all are given. So using that, we get it into this form. We apply Laplace transform. Then finally we get I21 of s to be of this part. Then we apply partial fractions to this. When you apply partial fractions to this, you make it like this. Get it in this form. To get A, I have to make B into something 0. So I put S is equal to -1. Then I get A. For B, I must put S equal to -10 by 26. And then I will get B. Then I will substitute that. And then I'll get my I21 of t. Then similarly, we did Thevenin's theorem we had to use to solve this sum. So all these resistor capacitor values we don't know. But we know that if I apply the open circuit voltage is given by this expression. The current is also given by this expression. So once I know this information, I can find my Z Thevenin. And then they tell I connect a 5 ohm resistor load. And when I apply Thevenin's theorem, I can get my load current. And for solving this, again, you need to use partial fractions. Then I told also of a simpler method, like a shortcut which you can refer after much practice of how to write these sort of things into a fast, simple way to find this. Okay. So when I like this was taught by my maths teacher, he had done once the shortcut, and I also liked it, and then I derived it and I tried it. So in the initial times, what I used to do is I used to just write down this, and then I will cross verify by actually multiplying, cross multiplying and checking if it is coming out to be the same. And then once I did that multiple times, I got confidence that this is the way, this is the formula. And then I used to use it nicely. Okay. So this formula can be useful once you have practiced it many times. All right. And then we verified also using our formula. Yeah. Then we saw compensation theorem. And we did a proof also of compensation theorem. And then we solved the sum. What is the change in I when there is a change in your delta, in your resistance? And then this three-phase system is there with an unbalanced load. Since we have the frequency, we can find out the impedance, reactance. And then in this, there was a common thing that it is 4 into this value. So you can get a common denominator. It was easy to get a common denominator. Once we got a common denominator, then it was easy to solve. Then we also considered how to actually solve these complex representations using easier methods, like actually using the sine and cosine trigonometric functions. Because in GATE exam, you will not have this complex mode of calculator. You have a simple calculator. In that case, you have to use these techniques. Okay. So those are all we have used, and then we verified and we got it. And also, in case your A is negative, that is in this case, if your A is negative, what you must do, I told. You must just add 180 plus theta. And then you get the correct answer. Okay, so any other doubts? Anyone has any doubts, any queries?
No, sir.
Okay, then if there are no queries, then we can end the meeting. Okay.
Okay, sir. Thank you, sir.
Okay.
Thank you, sir. Good night.
Thank you. Yeah, good night. Bye.
Thank you, sir.
Thank you, sir.